Welcome to this lesson on decimal to binary conversion. Every day, we use decimal numbers without even thinking about it. Numbers like 5, 18, 42, and 255 are all decimal numbers. This is the number system that humans use naturally in everyday life. However, computers cannot process decimal numbers directly. A computer understands only two digits, 0 and 1. This is called the binary number system. So, whenever you enter a decimal number, the computer first converts it into binary before it stores the data or performs any calculations. For example, the decimal number 5 becomes 101 in binary, the decimal number 10 becomes 1010, and the decimal number 25 becomes 11,001. Don't worry, you do not need to memorize these conversions yet. The important thing is to understand why computers convert decimal numbers into binary. In this lesson, you'll learn two easy and reliable methods for converting decimal numbers into binary. By the end of this lesson, you'll be able to solve conversion questions quickly, accurately, and confidently in your Edexcel IGCSE computer science exam. Now, let's learn the first method for converting a decimal number into binary. This method is called repeated division by 2. It is one of the most reliable methods, and it works for any decimal number. Let's go through the steps, one by one. Step 1. Divide the decimal number by 2. Step 2. Write down the remainder. The remainder will always be either 0 or 1. Step 3. Take the quotient and divide it by 2 again. Continue this process until the quotient becomes 0. Step 4. Finally, read all the remainders from bottom to top. That sequence of digits is the binary number. Now, let's look at an example. We want to convert 13 into binary. First, 13 divided by 2 gives a quotient of 6 with a remainder of 1. Next, 6 divided by 2 gives 3 with a remainder of 0. Then, 3 divided by 2 gives 1 with a remainder of 1. Finally, 1 divided by 2 gives 0 with a remainder of 1. Now, the quotient is 0, so we stop. The remainders, from top to bottom, are 1, 0, 1, 1. But remember, we do not read them from top to bottom. We read them from bottom to top. So, the binary number is 1, 1, 0, 1. Therefore, 13 in decimal is equal to 1101 in binary. This simple 4-step method can be used to convert any decimal number into binary. Now, let's practice using the repeated division method. In this example, we will convert 25 from decimal into binary. First, write the decimal number, 25. Now, divide 25 by 2. The quotient is 12, and the remainder is 1. Write down the remainder. Next, replace 25 with the quotient, 12. Now divide 12 by 2. The quotient is 6, and the remainder is 0. Again, write down the remainder. Next, divide 6 by 2. The quotient is 3, and the remainder is 0. Now, divide 3 by 2. The quotient is 1, and the remainder is 1. Finally, divide 1 by 2. The quotient becomes 0, and the remainder is 1. Since the quotient is now 0, we stop the process. The remainders, from top to bottom, are 1, 0, 0, 1, 1. But remember, we always read the remainders from bottom to top, so the binary answer becomes 1, 1, 0, 0, 1. Therefore, 25 in decimal is equal to 11,001 in binary. This method works because every decimal number can be broken down into powers of 2. Now it's your turn. Try converting 13, 19, 27, 45, 63, 75, 100, and 128 into binary using the same steps. Always divide by 2. Write each remainder carefully and remember to read the remainders from bottom to top. The more you practice, the faster and more accurate you'll become. Now, let's learn the second method for converting decimal numbers into binary. This is called the binary place value method. It is the recommended method for Edexcel examinations because it is faster and easier once you understand the binary place values. Let's look at the steps. Step 1. First, write the binary place values. For numbers up to 255, the place values are 128, 64, 32, 16, 8, 4, 2, and 1. Step 2. Start with the largest place value that is less than or equal to the decimal number. Place a 1 under that value. Then, subtract it from the decimal number. Continue the same process, using the remaining value, until the remainder becomes 0. Let's see how it works, with an example. We want to convert 25 into binary. First, look for the largest place value that is less than or equal to 25. That is 16. So, place a 1 under 16. Now subtract 25 minus 16 equals 9. Next, look at the remainder. 9. The largest place value, less than or equal to 9, is 8. Place another one under 8. Now, subtract 9 minus 8 equals 1. Finally, the largest place value, less than or equal to 1, is 1 itself. Place a 1 under 1. Now, 1 minus 1 equals 0. The remaining place values receive zeros. Reading the digits from left to right, we get 1, 1, 0, 0, 1. Therefore, 25 in decimal is equal to 11,001 in binary. The key idea is simple. We build the decimal number by selecting the correct binary place values and placing ones where they are used and zeros where they are not. With a little practice, this method becomes very fast and is ideal for solving Edexcel IGCSE computer science exam questions. Now, let's work through another example using the binary place value method. Our goal is to convert 25 into binary. First, write the binary place values: 128, 64, 32, 16, 8, 4, 2, and 1. Now, start with the largest place value, that is less than or equal to 25. That value is 16, so write a 1 under 16. Now, subtract 25 minus 16 equals 9. Next, look at the remaining value, 9. The largest place value, less than or equal to 9, is 8. Write a 1 under 8. Now, subtract 9 minus 8 equals 1. Next, look at the remaining value, 1. The largest place value, less than or equal to 1, is 1 itself. Write a 1 under 1. Now, 1 minus 1 equals 0. The remaining place values, 128, 64, 32, 4, and 2, are not used. So, we write 0 in those positions. Now, read the binary digits from left to right. We get 0, 0, 0, 1, 1, 0, 0, 1. Ignoring the leading zeros, the binary answer is 11,001. Let's verify our answer. The 1 under 16 represents 2 to the power of 4. The 1 under 8 represents 2 to the power of 3. And the 1 under 1 represents 2 to the power of 0. Adding these values together, 16 plus 8 plus 1 equals 25. Therefore, 25 in decimal is equal to 11,001 in binary. This method is quick, logical, and one of the fastest ways to solve binary conversion questions in your Edexcel IGCSE computer science exam. Now, let's look at another example using the binary place value method. This time, we'll convert 42 into binary. First, write the binary place values: 128, 64, 32, 16, 8, 4, 2, and 1. Now, start with the largest place value, that is less than or equal to 42. That value is 32. So, write a 1 under 32. Now subtract 42 minus 32 equals 10. Next, look at the remaining value, 10. The largest place value, less than or equal to 10, is 8. Write a 1 under 8. Now subtract 10 minus 8 equals 2. Next, look at the remaining value, 2. The largest place value, less than or equal to 2, is 2 itself. Write a 1 under 2. Now subtract 2 minus 2 equals 0.